Hello, this is Bill. He is a developer who tirelessly works on solving interesting problems. Unfortunately, Bill works at Megacorp, where his boss has some interesting ideas of what it means to be computable. One day, he got a memo from his boss.
Bill Brick. There are people signing up for our mailing list who aren't real people. This is completely unacceptable. You need to write one of your program thingies to make it such that only real people can sign up for the mailing list. Stat. Also, I want you to change the color of the button on our homepage. The blue is just too professional looking. We want to be more appealing to a general audience. You should make the color of the text bright neon green. That will stand out and make people want to click on the button. Get to work, Boss Fig.
The last item, the neon green button, is quite easy for Bill to do, no matter how much it pains him. However, the first task is impossible for him to do with the standard algorithm database approach. He would need access to the database of everyone and their email addresses. Impossible. Bill, however, doesn't back down from problems, whether or not they are effectively computable. So Bill thinks about it. If he, in real life, had to solve a problem like that, where he couldn't get definitive information, he would ask his friends about it. His friends would then think about it and reply with their best idea as to what the correct answer was, and he would pick the one which he trusted most, based on the opinions of his friends. Bill realized he could do this with computers as well. However, instead of asking his friends, the computer would send queries to other computers, databases, sensors, and even other people through crowd computing platforms like Mechanical Turk. Unfortunately, these sources have undesirable properties for computation. They take varying amounts of time to provide an answer, ranging from milliseconds to hours, or even days. They are unreliable, and Bill has varying levels of trust in them. And what's more, some of them even cost money to access. Bill realized that this number of variables was too much. If he wrote an ad hoc program which used these sources of information, it would be too complex. So he did some research and found a solution. Contributional implementations. In a contributional implementation, there are three main components: the selector, the aggregator, and a bunch of sources. Each of the sources represents a single opinion. They can either be other computers, databases, sensors, people online, or anything else which can be queried by a computer. Each source also has an associated cost and trust level. When the CI is run, it is given some inputs and a budget. The selector uses this information to choose a set of sources based on the costs and trusts of the sources. The aggregator then connects and listens for responses from the sources. Each of the sources is sent the inputs, and it takes some amount of time to generate a response. As the sources generate responses, the aggregator combines them together, creating a single aggregated result. As new results come in from sources, the aggregator adds them to the aggregated result, improving the quality of the answer. The program which uses the contributional implementation then gets access to an improving estimate of a particular value. What's more, the selectors and aggregators are completely interchangeable, so Bill can just use a selector someone else wrote. He doesn't even have to write it himself. Bill writes a bunch of sources, querying phone databases, social networks, performing search queries, and asking people for confirmations. He then plugs them into a CI and successfully creates a system which can check if you are real or not. Now Bill has achieved the impossible, which satisfies Boss Fig. Awesome. The only downside is now his co-workers think he's some kind of computer god. Bill thinks he can live with it.